One more time, we are learning how to read the standard normal distribution table. And I did mention last time, and I am still mentioning that when you're working with the experiments, some of the experiments shall have higher denominations. And what I mean by higher denominations, I mean the value that shall be assigned to them will be a very big number, yeah? The number will be big. But what do you need when the number is big? So what you need to do is to convert those huge numbers into a z-score, right? Into a certain number, which we usually call a z-score. And a z-score usually falls in the range, okay? Falls in the range between 0 and 1. A z-score falls in the range a z-score falls in the range between 0 and 4. Then the z-score is the one that leads you to the probabilities, that fall in the range of 0 and 1. So it is very important that we mark that, right? So what we are trying to do is that we need to show you the probabilities, okay? The probabilities between 0 and 1. So how do you now find these respective probabilities, eh? I mean, that is the question that we are working with. How do you go ahead and find these probabilities? So we are saying that when you are given a z-score, that you usually calculate by saying the number, x minus the mean mu divided by the standard deviation. This gives you a z-score. Any number, let's assume a z-score that you find is 3.2, right? Okay, 3.2. I made mention that these z-scores that you find, a z-score shall have 2 decimal places. That's a quick reminder. 2 decimal places, which simply means if you have 3.2, this should be written as 3.20, like that. Okay, if you have 2.5, should be written as 2.50. So now, if you have, for example, 2.53, this number can be separated into 2 divisions, okay? Follow nicely. You can write this as 2.5 first, and the other part as 0.03. So that when you add this, you can go back to 2.53. If you have number 3.14, this can be written as 3.1, then is 0.04, like that. So now, listen, when you look at the standard normal distribution table, on top here, it has 2 decimal places, and then vertically, it has one decimal places. So if you are asked to find a corresponding probability to a certain number, let's say z is equal to 2.53. If you want a probability that z is equal to 2.3, then the other one is z is greater than 2.53. The other one is z is less than 2.53. How do you work with this? That's a question we have. So the first step that you need to do is to make sure that we separate this number 2.3 into 2 parts, 2.5 and 0.03. Okay. So when we are reading our z-score, we are going to look for where there is 2.5 first. And when we locate 2.5, we draw a line like this. Are you following? Are you able to hear me clearly?
Yes.
Yes. You draw a line like this. Then you come to where there is 0.03, which is this line. Draw a specific line. You see where they meet? This is 0.0057. 0.0057. Now, when you look at 0.0057, this is defined according to this table that you're using. You've seen the way how the table is. it defines this as the number after the z-score. Remember, your z-score sits like this on the table. This is how it sits. It sits like this. There is a z-score here, which is in our case 3.53. So they are saying that this probability actually, it corresponds to this area, the area that is greater than, the z-score. So this is our area 0.0057. This is a probability. Now we recorded that this area from 0 here going to the right, it is 0.5. That's the probability. And from 0 going to the negative is 0.5. So that the total probability can be equal to what? To 1. Okay. So we know that the whole lot of the right-hand side, the probability is 0.5. So now, if we ask you to find the probability that z is equal to 2.53, which means we are asking you to find this probability from 0 up to 3.53, this area alone, or this probability, how much is this probability? All right. How can we go about finding this c? We know that the whole lot of it from 0 going this right is 0.5, but after the z-score, we already know what is there is this one, 0.0057. How can we find this area that is missing between 0 and the 3.53? What did we say? How do you find that one? How can you find that probability? Hello? Do you still remember? How do you find that probability? Z is equal to 2.53, which is equal to what? What is the probability?
Probability should be 0.5, because the whole of that it's 1. The half of this, it's 0.5. So normally it was supposed to be a 0.5 minus this part. This is it a 0.
Yeah, 0.5 minus 0.0057. Correct? Yeah, exactly. So this is what he has said. So, he says that the right hand side, all out of it to the right is 0.5. So this probability that we have found is just for the area afterwards. So if you want the area from 0 up to this, it will just be 0.5 minus that area. It will give us this capice that we have remained with. So just say 0.5 minus 0.0057. Yeah. What is the answer? That is the probability. It should be 0. What? This is very important. We will need it again.
It will be something like 0.443.
0.443. 443. Yeah, that is the probability that z is equal to that number. Okay. What about the probability that z is greater than 2.53? What is the probability that z is greater than this number, which means it's right after this number? What is the probability?
It's the same, 0.057.
Yes, thank you. We already have it, correct? It's just 0.0057. We already have it. Okay. Cash people were following last time. What about less than now? Less than this z-score, this value, going all the way up to this. How can you find?
It will be 1 minus 0.057.
Yeah, exactly. So we know that the whole total probability under this curve is 1. So we can just deduct what we already have this side from 1. Then it will give us everything going backward. So you can say just 1 minus 0.0057. That gives you the probability that z is less than 2.53. This is the message that we have been sending again and again. Is that clear? Do we have any question? Or we need to try another one? Let's try another one as a second example. Now we are looking for the probability of 1.55. What's the way forward from here? This is Z. So we say Z is equal to that. The other one is Z is less than, or first this Z is greater than 1.55. Then the other Z is what? Is less than 1.55. How do you work with this? First of all, we break it down. 1.5 and 0.05, correct?
Yes.
Then you can guide at what we do from here.
We look for where there's 1.5.
Yes, 1.5 is this side.
Then we start looking for 0.05.
Which is this side.
Yes.
So they meet somewhere here. This is 0.0606. Correct? So this area is said to be after what? After the Z-score, and our Z-score is 1.55, correct? So this is the area, 0.066. All right, so now, how do we find the area that is Z is equal to 1.5? Which means we are looking for which area? We are looking for this area. That's what we say. How do you find it?
To be 0.5.
0.5
minus
less 0.060.
Yes.
Which is how much? This is how much?
0.4.
0.4.
394.
394. This is the probability that Z is equal to that specific number. What about less? Z is less than that number.
To be 1 minus 0.0606.
Yeah.
It will be
like
9.
When you deduct 0.9,
394.
9394. As simple as that. Is there any question? Do you have any question? Hello? Is there any question? Does someone have any question on how you read the standard normal distribution table? Okay. Let's get to this work. I think this is the same work that we did together again. Though I'll still give you this same work. I want you to go and try just within this same class. You know, these are quite easy stuffs. You already know them. Let me interpret this one. Okay. Are you able to see the first question here? This one. Question 1. You can see it, right?
Yes.
Partially.
Okay. Let me just try to flip and try to zoom so that there's peace in the land. Now you can see it, correct?
Yes.
This is how questions come. A recent study of the hourly wages of bricklayers in the construction industry showed that the mean is 20 and the standard deviation is 3.20. Can you assume a standard normal probability distribution? If we selected bricklayers at random, what is the probability that the wage is less than 19? What do we do from here? Since you are using standard normal distribution, I think I explained last time. What do you think we can do? The steps, what are the steps?
This one, it's above the Z, which is between 0 and 1. So we will need to subtract this 19 minus the 20 over 3.2.
Okay, thank you very much. Just there, before you go, yeah, I like the way how you are doing things. You are not memorizing, eh? You are saying things. Let me just help you to replace by putting the technical words. So you simply calculate a z-score, okay? And you say the z-score is what? X minus the mean, which is mu, divided by the standard deviation. You calculate a z-score in such a case. And you can go ahead. You said, what is our x? Our x is what? And they are
19.
saying z is less than I. So you don't put equals in our case here. You should put z is less than 19 minus the mean, 20 divided by the standard deviation of 3.20. You're following, right? So z is less than what? 19 minus that is negative 1 over 3.20. What do you get? Z is less than what?
0.3125.
0.0125. Correct?
0.3.
When you say 1 divided by 3.20, what do you find? What answer do you find?
Is that answer which she's saying it's 0.3125.
Or is 0.3125 and the negative? When
Yes.
you leave this to two decimal places, this is rounded up as negative 0.31, right? All right?
Yes.
So when you go to your table, you're looking for the probability that Z is less than negative 0.31. This, I said, is equal when you go to that table. As Z is greater than, then you put a positive number. You know, if you put that, you flip this, you can have 0.31. I said these probabilities, they are equal to each other. Correct? So that's what we'll
Yes.
be looking for. Yeah, we'll be looking for that. Okay, let's go to something, this other one. The B1, I think we can do the conversions in advance so that when you go to the table, we are just, you know, it's easy to work with. This one for 22 minus 20 divided by 3.20, what is the Z? And actually Z is greater than, it's more than. More than simply means greater than. No one should fail a question under standard normal distribution.
This one, it will
This
give us 0.625.
You see?
625.
0.625. So we can say Z is greater than 0.63, correct?
Yes.
So this is 63. Keep these figures, we need them. First of all, have I lost anyone here? Is there anyone who is lost or who needs clarity? No clarity, teacher, you can continue. All right. Let's convert these that are in between. Keep these figures that we have, right? This one is write them somewhere. This one is greater than 0.63, right? Then the other one is less than negative 0.31, which is same as greater than 0.31, right? Let's convert this one. This one is 22 and 24. The one for 22, we have already found it is 0.63, correct? We need just for this one. 24 minus 20 divided by 3.20, which is 4 divided by 3.20. Z is equal to what? Z will be equal to what?
This one, was it 24 or 22?
There was 22 and 24. The 22 and we have already found it. It is 0.63, isn't it?
Oh,
We had
this
already
other
done.
side.
Yes.
Z is equal to 0.625.
Is it going to be 0? I doubt. This is 4 divided by 3
That is for 22.
for
So
24.
For 24 is 1.25.
1.25, which can be 1 point, or just like that, 1.25.
Yes.
Okay, it is already in 2 decimal places. Okay. Then from here, let's go now to the table. Let's go. Let's go to the table. I think we'll do things quickly when we get to the table, correct? You see how easy these stuffs are. Let's start with that first one. It was the Z is less than what? Z is less than negative 0.31. I say that this is same as Z is greater than what? 0.31, correct?
Yes.
Yes. So how do you go about this? First of all, break this down to 0.3 and 0.01, correct?
Yes.
So 0.3 and 0.01, they meet here. The probability is what? 0.3783. This probability is where? Is after 0.31. It's this side, correct?
Yes.
Is this hard? No. It's not.
Yeah. Wow.
So you've seen, huh? So what is the probability that Z is greater than 0.31? It is this same area that we have already found. It's already after this 0.31, correct?
Yes.
Now, what was the second question? That the one for Z was greater than what? For 22, that one. 0.63.
Yeah.
It was greater than. It was not equal. Eh? They were asking
No,
greater.
it was greater than.
Which means it's 0.6 and 0. What? 0.3.
0.3.
You come on where there is 0.6, like this. And where there is 0.3, which is this one. Which area is this? 0.26 and 43. This is already the area greater than the number you are talking about, isn't it?
Yes.
This is already the area greater than 0.63. Am I too fast? Maybe. Maybe I'm too fast. Class, can you remind me that teacher, you can slow down. So this is what you find. So what if they ask that the Z is equal to this number? you would have found this area now, isn't it?
Yes.
You know, the same stuff that we are doing. If they say Z is less than this number, you'd have subtracted this from 1 so that it gives you the rest of the stuff. Is that clear?
Yes.
People are quiet. The other people are not hearing them. What are you saying? Do you have any questions? Hasn't?
I'm hearing, sir.
But you are not following.
Yeah, much better. I'm following.
Yeah.
I'll go. Yeah, I'm following.
Okay.
Mm.
Let's proceed then to the last one. The last one was like this. Look at the way how it was. It was 2 parts. There was a part which was the 1 point what? It was 0.63.
5.
And which other area?
0.
1.25.
1.25.
Mm-hmm.
So which area do they want? They want this area in between. This one. How can you find this area?
0.63 subtract it with 1.225.
Interesting. How can you find this area, Mara?
Maybe we find first the, what did you call? The probability for 0.63 and the probability for 1.25. Then among these, from 0 going to this, where there's 1.25, the whole of it, it's 0.5. Then these probabilities which we are going to find for 0.63 and 1.25, we are going to subtract from that same 5. So maybe if we put the 1.5
so look,
we
you
will
have
know.
to subtract this probability.
So maybe we find first the 1.25.
Yes, this probability after this. We deduct it, this area, we deduct it. Also, we find this probability between 0 and 63, right? This area.
Yes.
We also deduct it from 5. So the total is 0.5 minus what probability? Z is equal to 0.63, which is this area. You deduct it, plus the probability Z is greater than 1.25. Have you followed, right? When you deduct this area, and also deduct this one, you remain with the blue area from 0.5, correct?
Yes.
Mugonga. Yeah, you will be fine. Now ask your questions. Okay, let's go. Let's find the one for 0.63. How do we find the one for 0.63? First of all, we need to find the area 0.6 and 0.03, right?
Yes.
0.6 and 0.03, they meet here. Which means this is the area after this number going this side, isn't it?
Yes.
Is the class following? This area that we have found, which is 0.2643, it's the whole area after this going this side. The whole lot of it going this side. Okay. But which one do we want to deduct? We just want to remove this, isn't it?
Yes.
We have already found the area from here going this side. So what we need, we just need the area after this 2.5. We remove it. So let's go and find the area afterwards. The one that is after 1.25, and remove it from this number. 1.25, it would be 1.2, right? And 0.05.
Yes.
So 1.2, 0.05, which is what? This is 0.1056. This is the area after this side, right? After 2.5,
Yes.
this side. So we can, from this total, you understand what I mean? Remember,
Yes.
from this total, this one, from this one,
Mm-hmm.
I've changed the approach. From this one, because this one starts from what? From 0.6 going this side. Now, from this total, we can deduct what comes after 1.25. And then you remain with that. Okay? So let's remove that. You remain with what? This minus 0.1056. So when you deduct from there, what is the probability?
0.1587.
0.1587. That is it. It's not even difficult. You've seen, eh? So just visualize, and then you should be good. At least we have tried a good number of the questions in standard normal. So what I want to do now, when we come next time, we're introducing hypothesis testing.